Good day, greetings. Today I will going to explain the series circuits. Two types of current are readily available to the consumer today. One is the direct current DC, in which ideally the flow of charge does not change in magnitude with time. The other is sinusoidal alternating current AC, in which the flow of charge is continuously changing the magnitude with respect to time. The methods and concepts are discussed in detail for direct current. In this battery, first one DC supply is battery. The potential difference between its terminals and the ability to cause that is the pressure charge to flow through the simple circuit if you are connecting a battery. The positive terminal attracts the electrons through the wire at the same rate at which electrons are supplied by the negative terminal based on the directions. That is one thing. If we consider the wire to be an ideal conductor, that is having no opposition, means no resistance, nothing, the potential difference V across the resistor equals to applied voltage of the battery. So input is, that is general. In competitive exam they may ask, in ideal conductor we are applying the voltage V, what is the output voltage? Voltage is also same, equal to the supply voltage. Now series resistors. Series resistor means this is a two-terminal device. This is called two-terminal device. For example, series means what? This is one resistance, this is another resistance, the another resistance, like that. Three resistance I have given for our example: R1, R2, R3. Every resistance is having the starting and finishing point. 1 and 2 is the starting point for the R1. 3, 4 are the starting and finishing points of the R2. 5, 6 are the starting and finishing points of the R3. Now, the ending point is connected to the starting point of the second next resistance. Similarly, here also, you will get the one circuit like this, and this is the input line. So, if you are applying the voltage here, the current is flowing if it is circuit is closed. Then the total resistance RT is equal to R1 plus R2 plus R3 up to Rn. Whatever may be the resistance are connected in series, so that is addition only, continuous addition. For example, a series resistors are there of voltage V applied here up to 30 volts. Say example, this is 10 ohm, 15 ohm, 25 ohm. Simple. According to our formula, RT is equal to 10 plus 15 plus 25. 25 is equal to how much? This is 50 ohm. So if we want to calculate current I, V by RT. So that is 230 divided by 50, 4.6. Like that we have to give the answer, 4.6. This is calculation of series resistance with calculation of current. In series circuits, all the resistances are connected in series. In the same way, current is same in all the resistances. The circuit is any combination of elements that will result in a continuous flow of charge or current to the configurations. Next you can see another example I will give, voltage distribution for this. Take three resistance as an example. This is 10 ohm, 30 ohm and 100 ohm. So R1 is equal to 10 ohm, R2 is equal to 30 ohm and R3 is equal to 100 ohm. If you want to calculate total resistance, RT is equal to 10 plus 30 plus 100 is equal to 140 ohm. The applied voltage, if you are taking applied voltage of 8.4 volts, applied voltage of 8.4 volts. So the current flowing in the circuit is voltage by resistance 8.4 by 140. How much this is? Nearly 0.06 amperes. This is the current of individual resistance under the total current flowing in the circuit. Now, voltage distribution. Voltage distribution in the sense V1. V1 means voltage across distance 1, that is equal to I into R1. V2 is equal to voltage across distance R2, I R2. V3 is equal to voltage across resistance 3 is equal to I R3. Because I is equal to IT, means total current. That is equal to V1 is equal to 0.06 into 10. V2 is equal to 0.06 into 30. V3 is equal to 0.06 into 100. So V1 is equal to 0.6. V2 is equal to 1.8 ohms and V3 is equal to 6 volts. So if you can total V, total is equal to 0.6 plus 1.8 plus 6 is equal to 8.4. So it should match. So if you are matching means this is correct. Now power distribution. Power distribution in a series circuit. Power distribution. Total power P is equal to P1 plus P2 plus P3 up to Pn. In number of resistances Pn. So same problem if you want to take our formula, total P is equal to Pt is equal to V1I1 because I is same plus V2I plus V3I up to Vni. It will be going up. And another formula also there, Pt is equal to I square R1 plus I square R2 plus I square R3. This also watts, this also watts. Units. Like that also you have to calculate. For you, one problem I will going to solve. The circuit is given. First I will draw the circuit. So this is applied voltage of battery through a battery of 36 volts. Resistances are 1, 2, 3. 1 kilo ohm. This is 2 kilo ohm. This is 3 kilo ohm. So first total resistance, as usually total resistance is equal to 1 plus 3 plus 2, 6 kilo ohm. So I is equal to V by R. I is equal to 36 divided by 6 into 1000 is equal to 6 milliamperes. So with this V1 is equal to IR1, that is equal to 6 into 10 to the power of minus 3 into 1, that is equal to this 1 into 10 to the power of 3 is equal to 6 volts. V2 is equal to IR2, 6 into 10 to the power of minus 3 into 3 into 10 to the power of 3 is equal to 18 volts. V3 is equal to IR3 is equal to 6 into 10 to the power of minus 3 into 2 into 10 to the power of 3 total volts. So the total voltage is 36 volts, same as applied voltage. Similarly, P1 is equal to I square R1 means 6 into 10 to the power of minus 3 whole square into 1 into 10 to the power of 3. P2 is equal to I square R2 6 into 10 to the power of minus 3 whole square into 3 into 10 to the power of 3. P3 is equal to I square R3 6 into 10 to the power of minus 3 whole square into 2 into 10 to the power of 3. So if you can calculate, the P1 value is 36 milliwatt. This is 36 milliwatt. This is 108 milliwatt. This is 72 milliwatt. So the total power is equal to P total is equal to P1 plus P2 plus P3. 36 plus 108 plus 72 into 10 to the power of minus 3 because milli is equal to 216 milliwatt. This is the answer. Like that only you have to calculate and you have to solve the problem by individual voltages, individual currents, individual powers and total resistance, like that. Next one is voltage division rule. Some others may give voltage divide rule also. So for easy calculation, always it should be 2 resistances. 3 resistance means we have to convert that into 2 resistances, then easily you can solve. The voltage across a series resistance or resistive elements will divide as the magnitude of the resistive values or resistive levels based on the ohms. In a series resistor circuit, the larger resistance, the more of the voltage it will capture. So more resistance means more voltage. So resistance is directly proportional to the voltage. The ratio of voltage across series resistance will be the same as the ratio of to their resistance levels. Voltage divide rule. For example, one example I will give you. This is a voltage supply connected to a 2 resistances. This is V or E. This is R1. So the voltage across the R1 is V1. Voltage across R2 is V2. If you want to calculate V1 without calculating current, V1 is equal to R1 into V divided by R1 plus R2. If you want to go V2 or calculate V2, R2 into V divided by R1 plus R2. Like that also we have to calculate. For example, 2 resistances are connected in series to a battery of 100 volts. This is 20, this is a 40 volts. So voltage across 20 is V20, voltage across 40 is V40. So the value of V20 means voltage across 20 ohm is equal to total voltage 100 according to the above formula, 100 into 20 by 20 plus 40. How much this one? 100 into 20 divided by 60. 33.33. This is called 33.33 volts. Similarly, V40 is equal to 100 into 40 divided by 60. This how much? 6.667. 66.67. So if you can add these two, you will get 100. So if you can add V2 plus V4, you will get the 100. So verified. Like that, you have to calculate. This is only voltage divide rule is applicable in series circuits only, but it can be applicable for other circuits also, but it should be condition is only two resistances for DC, two impedances in AC. AC also we are going to solve. No. Next class, I will going to explain parallel circuits, current division rule. Now, series circuits with individual voltage drop across individual resistances, individual powers, total resistance in series circuits we calculated. Next class, what is parallel circuit and how the current will be divided, how to calculate the total resistance, and what are the conditions, how to calculate power and current division method. Like that we are going to discuss for next class. Okay, thank you very much. Please subscribe my channel. Thank you.